Hello and welcome to this video about schematic diagrams and circuits. We're just going to look at basic schematic diagrams, how to draw those and read those, and what a simple circuit is. And don't worry, we won't get anywhere near this complicated at all this year. So this is just a schematic drawing for the circuit board of a solar-powered garden light. So what is a schematic diagram? It's basically a graphic representation of an electric circuit. It uses very standardized symbols that represent the different circuit components. Here we have our circuit, we have our potential difference, the battery, we have a switch that's closed, so this is a closed circuit, and we have our light bulb, which is also a resistor as well. The wires are connecting all of these. Here is the schematic diagram, and we're going to take a look at the different symbols that represent each of these components. So in a schematic diagram, we have wires or conductors. They look like this in real life, and we symbolize those with lines in our schematic. We have resistors or circuit loads. Resistors will look like this in real life. They may realize that a little light bulb also is a type of resistor. It offers resistance as well. The symbol in our diagram for a resistor is this. You might see it like this as well. A light bulb is going to look kind of similar because it has some resistance across that filament with a little circle around it. You may also see simply a symbol like this for a light bulb. You might see something like this, a plug, right? Symbolized like this or this. You might see some other symbols other than these, but these are the most common. These are the ones that we'll be using in our schematic diagrams. A battery is an important component in our schematic diagrams, and when we have these are the wires right here, this would be the symbol for the battery or the potential difference. You might see it look like this with multiple cells involved. If we have a switch like this, this is what those are symbolized like in our schematic diagrams. This switch is open right now. If this is brought down so that it connects with this metal piece here, it is a closed switch. A capacitor, we can see one that looks like this, or the parallel plate capacitors as well. Those are different kind of capacitor, but capacitors are symbolized like this. You might see them like this sometimes as well. So what is an electric circuit? Well, an electric circuit is simply a set of electrical components that are connected so they can provide one or more complete paths for the movement of charge. So you can see this is an electric circuit because the set of electrical components here are connected so that they provide movement of charge. A load is any element in the circuit that dissipates energy. A light bulb or a group of light bulbs would do that. This light bulb here is the load. It's dissipating energy. A simple circuit consists of a source of potential difference in electrical energy, and that would be the battery. And it also consists of a load. The light bulb or light bulbs might be included. This switch is not necessary for the simple circuit, but it's included in there, just showing what a switch would look like. We can have our circuit closed or open. A closed circuit is simply a closed loop path for electrons to follow. This is a closed circuit right now. If we were to open this switch, or if we were to cut one of these wires or remove them from being connected here, we would then have an open circuit where we have no complete path. So no charge can flow and there is no current in an open circuit. You've probably seen this term before, EMF in lowercase letters. EMF of a circuit is simply the source of potential difference in electrical energy in that circuit. The EMF source, some examples of that would be batteries and generators, any device that would increase the potential energy of charges that are moving around in the circuit. Realize also that a battery in a circuit behaves as if it contains both an EMF source and some internal resistance. But we're going to assume that this internal resistance that's in the battery is insignificant. So that will be negligible in any of our calculations, and we'll simply look at a battery as an EMF source. So one parting comment. the potential difference across a load. So here's our load, remember. The potential difference across there is going to equal the terminal voltage. And in this case, let's take an example. If our potential difference across the bulb in a flashlight is 3.5 volts, what's the potential difference across the combination of batteries that are used to power it? It's going to also be 3.5 volts. Advanced ideas, the conceptual challenge in your book, or try asking any other questions or anything else that's interesting to you. Maybe you'd like to research what a short circuit is. Tell me what that is and why those might be dangerous. Look forward to seeing what you come up with, and we'll see you in class.